Hi, I'm Fred. I'm heading the machine learning team over at Encord. I'm super excited to be sitting here right now because in a year from now, or maybe 2 years from now, you'll see models that can do so much more and they will fuse so many more modalities. To help foster that development, we have developed the largest dataset in the world of multimodal data. So what we've built is a dataset of 100 million rows of pairs of text and image, video, audio, and 3D point clouds. To do that, we sourced a lot of data from a lot of open source datasets. We curated it very carefully. All this data will feed into developing models similar to the well-known CLIP model. So with this new dataset, you'll be able to build a CLIP model, but on a much more diverse set of modalities. CLIP has been in the past used to create diffusion models that can generate images from text, for instance. It has also been used for data curation and for many other applications. And in a similar vein, we imagine that this dataset will be the sort of ignition for other models and other applications where you need more modalities than just image and text. So it's a dataset that can be used for pre-training contrastive models. There's also a post-training part of the dataset, which is of very high quality. And there's further an evaluation piece, which is of utmost quality as well. So diving a bit deeper into these three datasets. The first one we built by sourcing around 5 million videos, 5 million audio files, 3 million images, and 800,000 point clouds. Then we used state-of-the-art retrieval models like the perception encoder. There's a model called CLAP for audio and one called Uni3D for these 3D point clouds. While we were building this dataset, we realized that when you're doing these retrieval tasks, you will have data that shows up a lot of times. And in order to break this sort of asymmetry, we had to build this second phase, or like this second post-training dataset. So for that, we developed graph-based algorithms for sampling data in a way where we don't have this oversampling of a few data points. On top of that, we also collected a lot of open source datasets that already come in sort of more than bimodal by nature. For example, video has a lot of bimodal data in the sense that you have the video, but you also have the audio. But then you need to be very careful that you only match up videos against audio where there's not, for instance, music overlaid or sort of artifacts within either the video or the audio. So a lot of care was put into that. And then, of course, we spend a lot of human hours verifying that all the pairs we make, they actually line up. So when I say in this dataset that this piece of audio matches this particular point cloud, then I actually know that a human looked at it and it actually does match up. And then finally, of course, there's this evaluation dataset. 5 people have consensus on every pair that these things are actually covering the same concept. So we really focus on both like scale, quality, and then this very, very premium quality evaluation. I think it's going to be very powerful, and I'm sure it's going to push forward the multimodal work on the AI front.